Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA subgroup. We have reached the year 2022, and this is our first meeting of the year, first of many, many, many meetings. As first among equals, we welcome Argenis Fernandez. Take it away, please, Argenis.
Thank you so much for having me, you guys. You don't know how thankful I am of the fact that you guys are giving me your time during a pandemic to have, to listen to what I have to say about a particular topic. So hopefully this won't be just me, giving you opinions, but there's also a lot of fact, a lot of trivia. Actually, I have quite a lot of interesting tidbits to hear about here and there. This session, we're going to give you guys a little bit of background here. Number one thing is, you excuse my mess of an office because I was building my wife's computer here, and I need to tidy up. So I apologize for the mess. But I'll tell you, this presentation was supposed to be. I submitted it for SQL Bits, and it was supposed to be a 20-minute session. One of those like very informal, quickie lightning round kind of thing. As I submitted it, I got pinged by a few other friends, like Anthony Santino, Ben Weissman, and others. They're like, "Hey, we have a session that's exactly the same as this one, literally the exact same topic, but we're making it a panel. So all of us are speaking on it. I was submitting it as a panel session. And why don't you join us?" So what I did is that my session did not get picked, but theirs did, and now I'm part of a panel, SQL Bits, to talk about this topic in particular. And it's not just Kubernetes for the Azure data professional; it's a larger Kubernetes conversation. And so I am wearing a very adequate T-shirt today. Here, I would say, folks, listen. This is an interactive session. If you guys want to chime in with questions, please do. At any point in time, feel free to interrupt me, and Kevin will help field these questions out for me. Let's try to keep it a conversation rather than me just giving you a spiel here. Anyway, like Kevin said, my name is Argenis. I'm a senior principal architect at UKG. UKG has recently been in the news, so I'll be the first one to acknowledge that we're extremely sorry about what happened. We got hit by ransomware, and it affected a lot of people across the United States. We are a provider of payroll services, so some of your paychecks may have been affected by the ransomware attack that we suffered. I don't speak officially on behalf of the company, but I feel bad because this stuff, shouldn't happen, and it does happen. But we're taking action and all of that. If you need more information on that, please feel free to reach out to me. So my pronouns, I'm a senior principal architect. By the way, they changed the titles of my company. It was a distinguished architect, and now I'm senior principal. It's all the same thing. I don't care about that. I'm a Microsoft Data Platform MVP. I've been for many years, with the exception of the periods when I've worked at Microsoft, because I've worked at Microsoft more than once. I'm also a Microsoft Certified Master, if you guys have ever heard of that certification. It was a rest in peace certification. Basically, it's been retired. It was the highest level of technical competency that can be validated by Microsoft when it comes to SQL Server. I'm a VMware V expert, and like I said before, I worked at in the SQL Server engineering team of Microsoft and other places where I do some pretty interesting things. In the SQL Server engineering group, I did a lot of stuff, and some of the things I did were directly related to this topic. Some of them I cannot even talk about today. Some of them were things that there were projects that were super interesting but got killed. Because that's just what happens at very big companies like Microsoft and AWS and Google and all those. Sometimes you operate as a startup within the company, right? You form a group of people that are working on certain thing, and then you try to position it as a product, and then the powers that be go like, no, thank you. We love the technology, but no, thank you. And so the technology, whatever we worked on, may be used in the future. It's actually being used, but can't talk much about it. There are things related to Kubernetes and containers and things like that. There is a patent out there. If you guys are interested in looking at that, there's a patent on conversion of software containers. If you're kind of curious as to what kind of stuff people do and think about at Microsoft when they're not telling much about it. Anyway, here's the agenda for today. This is a short session. Don't expect me to be here for a full hour just talking about Kubernetes and stuff, because that's not number one. I don't want to talk about Kubernetes for an hour right now, because that's all I've been doing at work, like literally working with Kubernetes all day. I'm also working with SQL Server, but a little bit only. And so I really don't want to pound on Kubernetes all day. I really just want to give you guys a little bit of background, and this is more of a level 100 to 100 session on why Kubernetes is relevant. Why you, as an Azure data professional, as somebody who works with Azure data products, why would you be interested in learning more about Kubernetes, and why do you want to dig in more into this? So this is not the dig in more into session, right? There are plenty of other sessions for that. I just want to get you guys in the right frame of mind when it comes to thinking about Kubernetes and why K8s are so powerful, right? And have gained so much popularity out there, because it's really interesting. It's really interesting, to see the progression of what's taking place in the market out there. So that's the agenda, right? We want to talk about Kubernetes and its background. We want to talk about containers and ephemerality. We want to talk about VMs versus containers, pros and cons of each. And then we'll talk about Azure data products that leverage Kubernetes, and we'll leave it at that. Right? I don't want to dig in any further. At that point, I'll just leave you guys to go dig into the specifics of all the different things that you may be interested in. And maybe Kevin and Malan and the other organizers of this user group will have me some other opportunity, and then we can chat a little bit further about all those other things that I consider important. Anyway, digging right into it. If you guys go back in the time machine of technology, right around 2013, a company called Docker shipped the first version of its product. And Docker revolutionized fundamentally how we do applications today. Okay, the concept of a container wasn't new to Docker, but it was fairly new to the x86, x64 world, in the sense that there were other operating systems that kind of had a similar technology. And I'm thinking, Sun Microsystems. So back in the day, had technology that worked similarly to containers, but they weren't really seen as a primary way of developing applications and delivering and implementing infrastructure, right? Creating infrastructure for those applications on top of containers. So if you think about Docker and containers, really, what you're doing is that you're removing a lot of the fat of the operating system, and you're creating something that's highly portable, right? You're creating something where you just put an application on top with very minimal tooling underneath the hood of the container itself, so you can just deploy that container wherever you want, right? And that's actually one of the great things about containers. Portability. You can just run them here, run them there. Now, containers themselves are compiled programs, so you can think of them not that way, right? Meaning they actually have executable binary code that may not run on a given platform. So it's not like you can just take a container that runs on x64, Intel or AMD processors, and run them on ARM processors. It won't run, right? Because that's not how it works. So there are other things at play there when it comes to portability. So they're not fully portable, but you know what? They are considered the first most paradigm for portability of applications today. And so that's important, because if I can run a container here on my local machine, I can see how something behaves in the context of a container. I can take it as is and just ship it to another data center or maybe the cloud, and then run it there, and I would expect it to behave the same way. So that's nice, right? As we start thinking into how things evolved, in 2015, the very first version of Kubernetes was shipped. And the idea behind Kubernetes was, well, how do you orchestrate and manage an immense amount of containers, right? Because when you're talking about applications and things like microservices, you're not thinking about very large monolithic kind of moving pieces, right? And we'll talk about SQL Server and how it's actually sort of a monolith and it isn't at the same time later on. But the point is that we have broken down our applications into microservices so we can distribute them in containers, but now we need something to orchestrate all these containers. And so Docker came up with something called Docker Compose, and that was sort of fine and dandy. There's been like 20 or 25 different technologies, not even kidding, to orchestrate containers in some way, shape, or form, right? And one of the ones that took like the most relevance out there was Kubernetes. And Kubernetes actually came out of a project codenamed Project 7 at Google, which turned into what's now known as Borg. And Borg powers Google Cloud. Okay, so much in the same way that Azure is powered by Service Fabric. If you guys don't know what Service Fabric is, you can go look it up. The source code for Service Fabric at some point was open sourced or something like that. So meaning a portion of it may have been open source. I can't quite remember what the status of that is these days. That is the underlying orchestrator for the cloud, right? So in Azure, you have Service Fabric. In Google Cloud, you have Borg. Now, I don't even know if they call it Borg these days because it's changed so much over the years. But regardless, Kubernetes was heavily influenced by Borg and how it operates, so that people will basically be able to run like a cloud, right? In the sense that they will have a high degree of automation, and there will be a lot of details that you would worry about when it comes to infrastructure that Kubernetes can completely isolate you from. And so when you start thinking about the fact that you are abstracting your infrastructure from your application, that leads to developers being more productive because they don't really have to worry about the minutia. They don't really have to worry about the details of when things run or how things run. They just run applications and they know that the Kubernetes is going to take care of a lot of things for them. So I'm working in my current job, I'm working with some devs that are used to working with Windows Server, VMs, and that kind of architecture, right? VMs, traditional networks, traditional data stores, no event management, no Kafka or anything like that. They're just used to working with things that way. When I show them how Kubernetes works, they go like, "Whoa, this is so much easier," right? It's a completely different paradigm. You start shifting your mentality toward focusing on what the code of the application should do, and not so much into this is going to connect to that, and what is the way to get to this? Do I need to receive a message in a certain way? Blah blah blah. Regardless, what I'm trying to say is Kubernetes is one of the pros for Kubernetes is for sure the ability to deploy applications fast and handle a lot of conditions that you would have to do a lot of manual work, a lot of automation around. You have to write a lot of code to not have to deal with manual processes when it comes to data center automation. So Kubernetes right now is has had over 100 releases since it shipped. I believe that number is way higher at this point. And it's so important that even big companies like VMware, whose source of income will be exclusively VMs, have now shifted toward Kubernetes and adopting containers as a first-class citizen for their offerings. If you guys haven't heard about VMware Tanzu, you should look at it, right? Especially if you're a VMware shop and you want to see how they actually work with containers, Tanzu is actually a pretty good product. And so start thinking about the fact that Kubernetes has gained so much relevance out there also means that every single technology company is looking at it or has already made offerings based on Kubernetes available to customers out there. So think about the big clouds, right? All the big clouds: Amazon, AWS, Azure, Google Cloud, Oracle, Alibaba, Tencent, and a whole bunch of other clouds have Kubernetes offerings today. Meaning they can help you deploy your Kubernetes clusters, and then you can deploy your containers on top of them, right, on your container images in pods right away. And they try to simplify how you do that, because in the end, what clouds are all about consumption, 100% about consumption, and your data, obviously having the most amount of data available that you upload as much data as you possibly can to their clouds, and that you run as many applications as you can in their clouds. That's what they want, right? That's consumption. And compute consumption from Kubernetes is a huge source of income for clouds, just like VMs are, right? So if you think about the old model, we'll talk more about that in a couple slides, but VMs consume compute, right? It's considered, the part of the compute income of any given cloud. Now Kubernetes is just astronomically growing in terms of consumption out there for all the clouds. Now, if a company is not offering you a Kubernetes based product, they are likely using Kubernetes themselves or are considering using Kubernetes in the near future. And that's a true statement for most companies out there. You should understand that this is really, really, really big, right? It's not just about applications. It's also about data. It's very much about data, and we'll talk about that a little bit more in just a second. Let's talk about containers and ephemerality. What does ephemerality mean? It means temporary. It means something that vanishes, right? So when you think about like VMs in the cloud, you always have ephemeral drives, right? You have an ephemeral drive where you can write data to it. You can maybe write it faster than you otherwise would to other storage offerings, but the data that you write there can go at any time, right? Your VM can be deallocated from the host that it's running on in the cloud, and the data that you had on that local drive, off it goes, right? So when you think about containers and what they are actually just binary images that get deployed, and they can be killed, right? A container can die, and a container can be restarted. But what happens to the data that you save within that container itself? If you save the data for your container within the container itself, the data will disappear with the container, right? So this is why it's a horrible idea to use databases. Getting into the database realm now. If you have something that stores data, fundamentally like a database, in a container, you don't want to save the data for that database inside the container itself. You want to do something else, right? And this is why persistent volumes exist. Persistent volumes are basically a way to tell a container, hey, look, you can run all you want, but when you're writing to this particular area, you're actually writing to this that sits over there, right? And it's an area of storage that can be replicated, across multiple zones and regions in the cloud and so forth and so on. Or if you sit on premises, it can be replicated across multiple data centers. The point is that you can have data that's being accessed by a container, right? Or in the case of Kubernetes, a pod, right? Because pods are what actually run containers in Kubernetes. You can have those containers access data that is persisted. And so if you start putting 2 and 2 together, this is really what gets you to a model where you can actually implement data stores in Kubernetes, right? So you're no longer running, microservices that are spin up and spun down very quickly. You are actually running databases and, other means of storing data that serve out of a container, but the data itself sits on persistent storage behind that container or that pod when talking about Kubernetes, right? So I was having a discussion with one of our engineering managers who comes from the old guard here in my company, and he said, "Well, I don't see databases being implemented in Kubernetes ever, or Kubernetes or databases and containers do not mix. You should not consider them as equally as things that work together." I fully disagree. As a matter of fact, I reckon that in 5 years, most of the databases that we see out there will probably be deployed on top of containers in some way or another, or they will actually adopt a model where they will scale out through the use of containers and not VMs. And we'll talk about VMs and containers in just a second. But I still want to push on this point because this is critical. A lot of folks out there are kind of being an obstacle to the future of implementing proper modern architectures in their environments because they don't feel that containers are viable for databases. I fully disagree. And we can have an hour-long conversation on this, but I'll tell you, you can have containers that run as as fast, and as efficient as a bare metal host. There you go. Because you know what? Containers, you don't actually have to run on top of hypervisors. We'll talk about that in the next slide. And I guess this is a great segue into that. You don't have to run containers on VMs, right? Think about what a Kubernetes cluster is. A Kubernetes cluster is basically just a bunch of hosts right, that are running pods inside of them. Now, the pods that are actually running your container images, where you deploy your container images to, they don't actually have to be running on top of a light hypervisor. They can. And if you're running in the cloud, more than likely you do, but you can run containers on bare metal. You absolutely can. And guess what? You will get the exact same performance as bare metal when you run containers that way. So if anyone tells you you cannot achieve performance on containers, oh, you are so wrong. You are very wrong. Okay, because you can run containers on bare metal and achieve bare metal performance. And here's the kicker: VMs, traditional VMs from like VMware, Hyper-V, or Nutanix AHV, or I don't know, KVM or whatever, those VMs can be super fast too. So it's not like you can just, if you need fast, you will run a container on bare metal. More than likely, you're going to run containers on containers and pods on top of a light hypervisor for a fundamental reason. Spectre and Meltdown. You guys remember those vulnerabilities at the CPU level? Where you looking into, where you can snoop on some of the workloads data. Yeah, that's the reason why you would run your containers on lightweight hypervisors, right? And or potentially just full blown VMs. I have seen many customers and companies, including mine, deploying containers or Kubernetes on top of VMs. So the hosts are actually hypervisors, right? So full blown hypervisors, and each Kubernetes host is actually a VM. And sometimes what happens is that you're deploying on top of a host, and each pod, it's actually powered by a little light hypervisor layer that still provides all of the isolation or goodness that a full-blown hypervisor can give you. But you're still, there are some trade-offs in terms of performance sometimes, and so forth and so on. But you can still do that, and more than likely you will, precisely because most of the time you can't trust all the code that runs in your data center. And that's a huge problem in security where, everyone in security is saying zero trust, zero trust, zero trust. Well, if you're running code, whatever it is, on the same host, you are, oops, sorry about that. If you're running code on your data center and it comes from a third party, you can't trust that third party code is not looking at you. And as a matter of fact, if you're providing a service to a customer and that customer can deploy code on their own, and you're running that code alongside some other customers, well, they can snoop on each other's workload unless you're isolating those workloads, right? And the classic way of doing it has been through VMs. So you can, through containers and lightweight VMs, you can achieve the same. So this is an interesting area of computing, right? Where you're making decisions on how to achieve better performance versus how to provide proper security and isolation of workloads as you deploy intensive applications out there. Anyway, the big takeaway is you can still deploy your databases on top of VMs. I'm sure 20 years from now somebody will still be doing that. Just like right now we have people running SQL 2000. I literally heard of a guy on Twitter who was running SQL 2000 on top of Windows Server 2000. Hey, all the power to them. But you know what? The model that you're following today for databases will stay with you. We stay with those databases for a good while. We have at work, we have thousands of SQL Server instances running on VMs and bare metal hosts. We're going to take all of that and move them to some other model. How does that model even look like? Some of them are going to land on VMs, some of them may land on containers. We may move everything to containers. We don't know, but it's a big undertaking, right? And the point is that technology doesn't really die. It just lives on forever in different forms. And that's I see that the same story is going to happen for databases.
Got a comment from Anders in chat that now if Microsoft would just quit telling our architect that SQL should not be run on containers.
I'm sorry, say that again?
So Anders in chat says, now if Microsoft would just quit telling our architect that SQL should not be on containers.
Okay, so see, this is why I was moving into this slide, because I wanted to talk about literally Microsoft products that run on containers. Okay, so let's talk about this for a second. When you're talking about dev and test, it makes perfect sense for you to run SQL Server on containers, right? And I'm just going to talk about SQL Server specifically, right? Pick on SQL Server because it's just one of the many products. SQL Server on containers is fantastic because you can run it on your Windows machine, you can run it on your Mac, you can run it on a Linux on your desktop because you're a hardcore fan of Linux and you want to run it there. So be it, right? Now, SQL Server you can also run on ARM because you have Azure SQL Database Edge, right? Is it called Azure SQL Edge? I don't even remember because I believe they changed the name now. Anyway, you have multiple ways of achieving the exact same. Having a database engine available to you so your application can query that database. You can do that locally, right? And it's great for dev and test. Now, if you start thinking like, okay, we're moving into a cloud environment. Does it make sense for you to run SQL Server containers if you're running your test environment in the cloud, or you have some interesting CI/CD pipeline going on thing? Why not? Makes perfect sense to me. No, number one thing, CI/CD pipelines are like the classic, perfect example for containers. If I can light up a container instance for my CI/CD pipeline, validating my database changes, and every time I check in some database code, why wouldn't I do that? That to me makes perfect sense. Now, it sounds easier said than done. I get it. The stuff is complex, right? I'm abstracting myself from a heck of a lot of details. But the thing is that you can achieve that. You can check in code to GitHub and have that GitHub trip up a CI/CD check-in or commit, trip up a CI/CD pipeline, and run a battery of tests against that code that you just checked in. That works great. And containers can actually be powering the databases that are involved in that CI/CD pipeline for that. Now, let's take that at another level. Let's say production. What's wrong with containers in production? Oh, you can run them on Windows? Okay, that's a story. Because SQL Server doesn't run on Windows containers. SQL Server does not run on Windows containers, and it won't run on Windows containers for a good while. Okay, because Microsoft does not have any plans to fix that, as far as I know. And if I'm breaking it, I'm sorry. I have no way. I don't see a foreseeable future where Microsoft is letting you run SQL Server on Windows containers. Just don't see that. Despite the fact that Kubernetes clusters can run Windows nodes, and you can run Windows containers on Kubernetes today, and tons of people are running Windows nodes today in Kubernetes, and that's kosher. That's approved. It works great. All right. It doesn't matter that you shouldn't run your SQL Server on containers. SQL Server on Linux is I was the PM for SQL PAL, right? The layer of software that enables SQL Server to run on Windows. I'm sorry, on Linux and Linux-based containers. I was the PM for that when I worked at SQL Server Engineering, and I can tell you, SQL PAL makes SQL Server scream, sometimes faster than Windows, and Microsoft doesn't like it when people say that. It's true. So forget about the fact that they cannot run fast. They can run fast. We talked about ephemerality, so the data will be preserved. You can deploy them faster. You can patch them faster. You can have tons of security around them. I don't even understand what's not to like. Oh, I get it. The fact that they're not running on a Windows VM and you're just used to that. That's a good point. And Microsoft will tell you, depending on what they see on your team, right? When in terms of knowledge and capabilities and skill set, whether you should look at SQL Server on containers or not. And on top of it all, the consultants that you get from Microsoft may not be very well versed in SQL Server on Linux and containers. This is true. So fundamentally, there is no reason why anyone shouldn't look at SQL Server on Linux and Linux-based containers because it runs great. If you have a piece of functionality that is tied to Windows and so forth and so on, like we do, you're gonna have a little bit of work to do before you can actually switch into that model. But I personally think that SQL Server and containers are all the rage, and they're going to be the future. So let's talk about the products that actually leverage Kubernetes and or containers from Microsoft. Number one, the one that I was talking about, SQL Server instances on Kubernetes. You can, of course, do deployments of SQL Server on top of Kubernetes. You can keep your secrets safeguarded, like your passwords and all that, so they're not passed along any command lines or anything like that. In a secure way, you can have configuration maps for all the settings that you handle in SQL Server and pass those along to the container. So you can actually even automate the process of managing SQL Server, right? If you need low latency, you can achieve low latency on whatever it is, whether you're talking workload, CPU intensive workload that needs power, or storage, because there are tons of great storage solutions for Kubernetes, right? Whether you run on-prem or you run in the cloud, there's tons of options there. You can achieve great performance. And on top of that, have you guys realized that patching a container doesn't actually involve patching the container? You're just rerunning the container. You literally pull the latest version of the container and run it. You kill the old container, light up a new one, off you go. You don't actually patch it. And that's actually super important, because you can patch an entire farm, thousands of SQL servers in seconds. Seconds. How long does it take you to patch 100 SQL servers today? Think about that. So that's real value, you guys, right? That's an architectural decision that may set up your business for failure or total success. Total success, because you can totally automate a lot of processes around the database that way. Okay, so SQL Server instances on Kubernetes. Again, Linux only Kubernetes nodes, but you're getting tons of performance, tons of capabilities, and there are a lot of things that you kind of move away from, like, oh, I need to have a failover cluster. Like, what does it even mean to have a failover cluster in a Kubernetes cluster? What is a failover cluster? It's basically two instances of SQL Server. One is actually turned off. One is actually accessing the storage. When this one dies, this one runs. Kubernetes does that for you. Kubernetes can hold the persistent volumes where your database resides. One container is looking at it. If this container dies, another one pops up and does the same thing. And you have super fine-grained control on how quickly that other container spins up. You can literally detect within a second if your SQL Server, if your SQL Server instance is not responding, and kick off another container to look at it. So you can be way aggressive on HA, on containers. It's nice. It's very nice. So that's one thing. SQL Server instances on Kubernetes are one thing. Big data clusters are a flavor of, if you guys don't know what SQL Server big data clusters are, they're basically a flavor of SQL Server that only runs on top of Kubernetes, right? Because what the SQL Server team wanted to do is create a product that helps you mash up all your relational and big data sorry about the pun of the redundancy there, on the same product. So you could run your queries against relational data sets and big data set, unstructured data sets from the same product, from the same infrastructure, and even more, be all encompassing and create data virtualization on top of that existing infrastructure. That's what big data clusters is. And there is no other means of deploying big data clusters other than Kubernetes. It requires Kubernetes, right? Because what the SQL Server team wanted to do is abstract themselves for how this thing runs and focus on the functionality of the product. And that's exactly what they achieved after making the deliberate choice of going Kubernetes only. It's a great product. Look at it if you haven't looked at it. The other product that's also super nice and only runs on Kubernetes is Azure Arc-enabled data services, which is a ridiculous name in my opinion, but that's how I ended up calling this thing. There's a bunch of flavors of Azure Arc-enabled data services. Some of the offerings include Azure Arc-enabled SQL Server managed instance, or is it Azure Arc-enabled managed instance? I don't even know, because Microsoft marketing is special when it comes to naming products. Point is, Arc enabling a database means, or a database product means, making it a managed offering, right? So the management of the infrastructure is left to you, but they have made the decision to implement all this stuff in Kubernetes precisely because they want you to minimize the amount of management that you have to do in your infrastructure. This is the thought behind it, right? This is how they come up with that product. And so now when you deploy SQL MI to Azure Arc-enabled SQL MI, all you're doing is deploying an image of SQL Server that talks to Azure for configuration and management. And then on top of that, you'll be able to deploy other things that are Azure-like on top of your regular Kubernetes cluster. Because Kubernetes clusters are so automated, right? They can do so many things for you that you really don't worry about a lot of the day-to-day operations that you want. And so you're keeping your data local if you have those concerns, or you have to have your data local for whatever reason, right? Because you may be forced by contract or what have you to have data locally, data locality. Well, that's a great use case. And the best part of all, the thing that I love about Kubernetes is that you can run workloads across multiple clouds, and you can shift workloads across multiple clouds. You can literally take something that you run on AKS, Azure's Kubernetes service today, and literally take it and place it on Amazon's Kubernetes service, EKS, I think it's called. Or you can just take it and run it on GKE, Google's Kubernetes engine, right? And then interesting things come up. You can start thinking about a future where your workloads may actually, your cloud becomes a commodity, and then you start, how you start getting charged, and you get constant feeds of pricing, and you can decide to switch from one cloud provider to the other for your workload. I actually have a patent on that. I don't want to brag here, but literally this, I kind of see the future that way, where you're running something today on one Kubernetes cluster on a given provider, but your compute is too expensive here. It's much cheaper over there. Can you just take it and move it? You should be able to. As a matter of fact, you can today, right? So this is really the future, and this is why Microsoft has embraced all of this. And we as data professionals, we need to really worry and really learn a lot more about Kubernetes and overall about the orchestration of containers out there. And to me, it's a fundamental part of the future for computing and for data management as well. Anyway, that's all I got for today, you guys. Like I said, this was meant to be a 20-minute session, but I went on, I guess, several rants here today. I am very thankful again for you guys having me, and I wish you all health in these trying times. And if you guys have any questions whatsoever, please hit me up either right now. I'm going to stay for a little while. You can email me at argenis@zeroxsql.com, or just tweet at me, dbargenis. Again, thank you, guys.
Thank you, Argenis. And we do have quite a few questions here. So
Awesome.
Let me start with Damu's question. So could we use this for maybe SQL Server upgrade projects, testing and using SQL Developer Edition, and then moving it to the actual machines in production?
Yes, absolutely, right. So that's actually one of my favorite use cases. So what are you actually testing when you're testing a SQL Server upgrade? You're not really validating an upgrade of infrastructure. It just so may happen that you end up in new servers and new storage, right? And you're actually checking, and that would actually throw your skew your upgrade testing results. With containers, all you do is, with containers and Kubernetes, all you do is just deploy the new version of SQL Server, create a new deployment, and stick a copy of your databases in there, and then run your workload against that. That, with today's technology around storage and snapshots and all that, that stuff gets super easy. You can make that happen super quick. So yes, it's absolutely a great way of testing it. Furthermore, backing out of things. So oops, we upgraded, didn't work. How do we go back? As long as you didn't upgrade, the database structures, like you didn't go from one major version of SQL Server to the other, you can still go back. Like rolling back to a CU has never been faster. You know what I mean? So this sort of things enable some interesting ways of operationalizing and managing databases for sure. Great
Makes
question.
sense. Next question is, suppose you have something like availability groups and with read-only replicas, could you still get that working if everything's hosted in Kubernetes?
All right, so availability groups, read-only replicas, Kubernetes. So this is one of those conversations that is kind of like frustrating to me, because I would love for the SQL Server team to dedicate a lot more to availability groups in Kubernetes right now. Unfortunately, they haven't. Right at the beginning, they were all excited and working with Red Hat and all these things, and a Kubernetes operator for availability groups came out, and they pulled it like 2 hours after. Like, I don't know what the story is right now, but AGs and Kubernetes right now, specifically for SQL Server instances on Kubernetes, it's not a great story, meaning it doesn't really exist. But I would expect Microsoft to look at that seriously at some point, like in the very near future. I think they have to, because they have already done so in other Kubernetes-based products, meaning you can do AGs in big data clusters today on Kubernetes, but you can't on SQL Server instances of Kubernetes, standalone instances of Kubernetes. And you can do AGs on Azure Arc-enabled managed instance. You can have replicas, but you cannot have that on SQL Server standalone. So you see, they just need to put their heads to it and get it done. And if anyone from the SQL Server team is watching this, hello, do it. What are we waiting for? I get that question all the time, and I ask that question all the time whenever I hear Bob Ward or Anna or Buck Woody just talking about this stuff. I remind them that Super Report Petro and any of the other PMs on SQL Server engineering team, I just remind them that it's super important. They need to look at it. Great question. Thank you.
Yeah, agreed that tooling is important there, and it's kind of lacking. Next question. How would licensing be affected by using Kubernetes?
It isn't. It works the exact same way as it does on VMs. You pay exactly the same way. So if you're running a container and your container is using 4 CPUs, you're paying for 4 CPUs. Cores. If you're running 4 cores, you're paying for 4 cores. Exactly the same way. It's the exact same licensing mechanism. You don't get any benefit from running on Kubernetes. Now, I don't know, and this is actually a great question, whether you can license an entire Kubernetes host and run all the containers you want. I believe so, but don't quote me on that. You should talk to your licensing expert. You know, we literally had, when I worked at the SQL Server engineering team, we had one guy, one PM who knew about licensing, and we would run all the licensing questions through him. He quit because the licensing is so complex, especially Microsoft licensing is so complex. It's just not fun. Don't talk to me about licensing because I know very little.
That's my excuse.
Right?
What are your thoughts on Windows Active Directory integration with SQL Server on Kubernetes?
That has gotten a lot better. So SQL Server on Linux and authentication has gotten a lot better, right? Like overall, that story is pretty solid these days. There's tooling even now with AD-UTIL that help you connect your SQL Server on Linux and also in containers to Active Directory. That stuff is going to get better. So yeah, they are definitely making improvements in that area, because one of the big things that has kept Microsoft relevant is Active Directory. It's like one of those things that's the sleeper product that just keeps you tied to their stuff. It's authentication. Authentication is everything, right? Why do you think a SQL Server cannot talk to Okta or Ping ID right these days, right? It's precisely because it makes it super sticky to the Microsoft ecosystem. So yeah, you can definitely expect some things work right now and some things will get better in the future.
Yeah, when you're using something like Realm D, there are walkthrough guides on how to set that up. It's more of a process than Active Directory on Windows, but like Argenis says, it's certainly doable.
Yeah, there's ways around things, and I like experimentation. So if you have a scenario that they haven't thought of, you should bring it to them and tell them, hey, look, I have a ton of instances, and I will continue paying you for them, but you're not fixing this. I keep reminding people that paying licensing to Microsoft is like paying taxes to Microsoft. Like, you should demand something for your money. Hey, fix this. Come on.
So SQL cannot run on Windows containers, but SQL can run on Kubernetes. That Kubernetes is running on Windows.
No.
To clarify the question, you mentioned Microsoft's not supporting Windows containers running SQL Server. You have to be running on Linux. You can host Kubernetes.
Go ahead. Finish it.
Oh, sorry, but that you can host Kubernetes on Windows running a SQL Server container.
So no. Let me explain. Kubernetes are clusters, right? Kubernetes, you can have one or more clusters. Every cluster is comprised of hosts. Hosts have operating systems. Okay, you cannot run. Well, at least you couldn't in the past. Now I believe that functionality is kind of weird these days. You couldn't run a Linux image on a Windows host, right? That works if you're using like Azure Stack HCI or what have you. I don't think that you can actually run Linux-based images on Windows hosts on Kubernetes. I don't think that works. Please correct me if I'm wrong. I would love for me to be wrong, but I don't think I'm wrong. Anyway, if you want what's supported right now, it's only running the SQL Server Linux-based container images on Kubernetes clusters. Okay, no, there is no such thing as SQL Server Windows-based container images. They don't exist. They used to exist. I believe they pulled them. I believe they even removed them from the repos. They had a bunch of issues with that, and they pulled them. So you cannot deploy SQL Server on Windows-based containers to a Kubernetes cluster, period. Now, you can have Windows hosts on a Kubernetes cluster, and you can deploy Windows containers running other applications, right? Whatever applications, like .NET Core stuff, .NET Framework stuff on Windows natively. You can run that. There's no problem. There's a bunch of limitations, and those are getting fixed because Microsoft is investing heavily in this area. There's a lot of PMs working on this, on the coastline side of things. That's the Windows org. At least
Yeah.
that's how it used to be called before I left.
Fair point on host, because host has a specific meaning in Kubernetes. What I meant was, for example, if you have Windows and you're running Docker desktop for Windows and you're using Linux containers, then you can have SQL Server on a Linux container running on that Windows machine.
I love that. So there's a few things in there, right? Windows 10 and Windows 11 can have the Windows subsystem for Linux. And the Windows subsystem for Linux would actually enable you to run Linux, they're basically like VMs, right, inside of Windows, and they actually integrate with Windows these days. You guys have probably seen that. When you install Docker Desktop, right, you can actually run Linux images on Linux VMs with Docker Desktop, or you can use the WSL integration, right? So you can run Linux-based images on Windows 10 and Windows 11. What I said about Kubernetes is completely separate from this. This is Docker realm, not Kubernetes realm. On the Docker realm, you can run it. As a matter of fact, I'm doing that right here on my computer, right? The one that I'm speaking to you guys from. Docker Desktop, Windows Services for Linux 2, the Windows subsystem for Linux 2. Sorry, Windows Services for Linux is an older thing, an even older thing. And then you can have Linux-based container images run on your computer. As a matter of fact, Docker Desktop has an option for running Kubernetes these days. You go into the settings, and you can enable a Kubernetes cluster that runs within your Windows machine, running Linux nodes. It's actually super cool. So you don't have to like deploy a Kubernetes cluster with 10 VMs by hand. You can just run Docker Desktop on your computers, on your PCs, of course. So Mac, I don't know what the story is on Mac. I assume that there's something similar. I don't use Macs, but that's how you do it, right? So this, as a matter of fact, I have a Kubernetes cluster on Docker Desktop on my computer. When I'm offline or I lose power, here, and my generator kicks in, but I lose internet connectivity. I can work on my local Kubernetes cluster. Once I'm done, I just update everything when I connect remotely, right? So it's a great way of working. Great question.
Sure. Next question. Calling back to the ephemeral nature of Kubernetes and persistent storage, do you have any tips or thoughts on database performance versus bare metal?
So this is an area where there's been a lot of work to make sure that the code path for an IO, as issued by a pod, is minimal. And I would argue that the work that has been done there is so great that the latency of the software stack induced by the fact that you're running on a Kubernetes cluster, it is so minimal that it's almost as if you were running directly on bare metal. So it's that good. And I would say that performance is pretty great. we can chat about this for hours. So this is a super interesting topic to me because I was a storage guy in another life. Uh, so we can chat about this for hours. But I would wager that there's within statistic deviation or within statistic error, performance difference between running on Kubernetes or running on bare metal. It should be nothing or close to nothing. The overhead, that is. Now, when you start thinking persistent volume in the cloud, that kind of thing, that's a completely different conversation, right? A persistent volume in the cloud sits on their storage offerings that the cloud has, and you're at the mercy of whatever performance you can get out of those devices. On premises, you can make it as fast as your storage device will go. Period. And it's the same in the cloud. It's just that you don't have any control over that. Make sense?
Yeah, that makes a lot of sense. Is it possible to access a SQL server running on Linux-based containers from a Windows laptop via SSMS?
Of course.
Yeah,
so one of the things you do in a Kubernetes cluster is that you can pull forward ports, or you can create a load balancer to get into a particular deployment. The traditional way of deploying SQL Server on a Kubernetes cluster is by creating a load balancer that will open up that load balancer to port 1433 or whatever port you choose. Hopefully, you're all running on 1433 anyway. From that load balancer into that SQL Server pod within the Kubernetes cluster. So you just hit that load balancer, and you're actually hitting the SQL Server itself. There's tons of other things that you can kind of run on top of your Kubernetes cluster. There's all sorts of network overlays, and it's a long conversation. Now, I'm not going to get into that, but you can most definitely access SQL Server running on your Kubernetes cluster from SSMS running on any machine. As long as you have the proper network connectivity, yes, there's no problem. Even locally, if you're working on Docker desktop and you run a Kubernetes cluster and you deploy SQL Server to it, the moment you create that load balancer, that's going to have an IP address and a port number, and you can launch SSMS on Windows and connect to that. There's no problem. Unfortunately, I don't have that deployed on my computer. Otherwise, I'll show it to you. Great question. What else do we have?
Are there any businesses you're aware of that are already using SQL Server on containers?
We are.
Makes sense.
That's all I can say.
Easy answer.
Yep. I literally have it deployed right now for this project we're working on. Now, I work on research. This project has not seen production yet, but that's the plan. We are going to production on containers at some point. Linux-based containers, by the way, because there are no Windows-based containers. So just to be perfectly clear, we are investing heavily on this. That's the future for us. I guess what that's another way of saying we don't want to run Windows on our data centers or the cloud. We want to run everything on top of Linux.
Yeah, that's kind of the norm.
Companies think that way. That this is one of our directives. We will no longer run Windows in our data centers at some point.
Yeah,
I know it sounds weird because I'm a Windows guy. I've been working with Windows Server since Windows NT 3.5 beta. But this is what it is, right? It's the new future. SQL Server continues to be there, though.
Right.
SQL Server is not going anywhere. Like literally, every single one of us can retire off SQL Server if we chose to. That's for sure.
All right. So it looks like we have answered all the questions from. Oh, maybe one more. No, that was a follow-up statement, not a question. Okay.
I'm not looking at the meetup, so I have no idea what you guys are talking about in that chat.
That's good. It's good. Mala says the most heartening line that we can retire off of SQL Server.
We could if we wanted to.
All right, everybody. Looks like we are out of questions, and therefore we're going to allow Argenis to go. We'll release the hostages, and he'll be able to take off. So with that, hopefully you've had a rather enjoyable learning experience tonight. And remember that this upcoming Monday is Shop Talk. Next Tuesday, we have William Assif and some of the Microsoft Docs folks talking about how we can work with Docs. And we'll continue on from there. So until we see each other again, everyone have a wonderful evening.
Stay safe, everybody.